Okay, in this video I'm going to be working through worksheet 5.5, I think it is, solving just a bunch of quadratic equations and all different methods. So this first one, I got 3x squared minus 8x equals, or minus 60 equals 0. My first thought is, can I factor it? It doesn't look like a real easy factor. Let's see, 3x and x, and 60 has a bunch of options, like 60 and 1, 30 and 2, 15 and 4, and I'm looking for a difference of 8. So let's see, 3 times 2 is 6. We got some more here. How about 6 and 10? That would be 18. Oh, 18 and 10. There we go. So I want that to be 6 and that to be 10. Does that work? So then I want a negative 16 plus, negative 18 plus 10, and that would give me the negative 8x. Yep. So then, of course, that's equal to 0. So that means that 3x plus 10 is equal to 0, or x minus 6 is equal to 0 because of the zero product rule. And if this is equal to 0, that means x is equal to 6. And this would mean that 3x is equal to negative 10, which means x is equal to negative 10 thirds. So that would be my two answers. Okay, this one here, I noticed that there is no middle term, or no, just an n, only n squared. So I'll just use my traditional solving methods, just undo everything. So add 11 to both sides, and I get 6n is equal to 11, or 6n squared is equal to 11. Divide by 6, and I get n squared is equal to 11 over 6. And then square root both sides, and I get n is equal to the square root of 11/6, or negative square root of 11/6. Okay, same thing here. Add a 3 to both sides, I get 3k squared is equal to 3. Divide by 3, I get k squared is equal to 1. Square root both sides, and I get k is equal to 1 or negative 1. Okay, that's the square root of 1. Okay, here's another one that doesn't lend itself, or I can't do it the traditional way because it has an x squared and an x. So I might be able to factor it, or I might just, maybe even if I could factor, I could throw in the quadratic formula just now because I don't want to bother with factoring right now. Okay, so that would be x is equal to a negative 5, which would be 5, plus or minus the square root of 25 minus 4ac, so that'd be 4 times 4 times negative 10, so actually going to be plus. So 4 times 4 is 16 times 10 is 160. 160, I said, all over 2 times 4, which is 8. So then we'll go ahead and simplify that. X is equal to 5 plus or minus the square root of 185 all over 8. Let's go off to the side here and see if we can do something with the 185. Is there any perfect square factors in there? Let's see, and 5 will go in there. So 5 will go in there 3 times 37. Oh, no, I don't think so. 37 is a prime, so that is my answer. So now remember, this means x equals 5 plus the square root of 185 over 8, or 5 minus the square root of 185 over 8. It's okay to write it this way, but you need to understand that it means it's two different answers. Okay, here's another one. I don't have 0 on the other side. So remember, you got to have 0 on the other side, whether you're using the quadratic formula or factoring. So first thing I do is subtract 2 from both sides. So that'd be negative 3k squared plus 8k minus 3 equals 0. And we could try factoring this. Or we could throw in the quadratic formula right. Let's see if it's factorable. So that'd be 3k, and that would be k. And then we'd have to get a difference of 8. Oh, I think that'll work. So if I put a 3 there and a 1 there, 9k minus 8k would be 9k minus 1k would be 8k. 8k, so that'd be plus and minus, which means we have 3k minus 1 equals 0, and k plus 3 equals 0. So this would give me a k equals negative 3, and this would give me a k equals, what, 1/3. Okay, here's another one that doesn't have a k, just has a k squared. So I'd subtract 51 from both sides, and I get negative k squared is equal to negative 49. Divide both sides by negative 1, and I get k squared is equal to 49, which means k is, well, that's an ugly k, sorry about that. That means k is equal to 7 or negative 7. There's another one that's not equal to 0. Got to get it equal to 0 first, so I subtract 3 from both sides, and I get 4x squared minus 2x minus 6 equals 0. And I notice I can divide everything by 2. So I divide both sides by 2, and I get 2x squared minus x minus 3 is equal to 0 divided by 2 is 0. And I think I can factor that. So we'll go boom, boom, boom equals 0. That'd be 2x and x. And I'll put a 3 there and a 1 there. So then I want my negative 3x and my positive 2x, and that'll give me that negative 1x in the middle. Perfect. So that means that 2x minus 3 is equal to 0, and x plus 1 is equal to 0, which means x equals negative 1, of course. And here we get x equals 3/2. And that's my answers. Here we go. Subtract 2 from both sides, so I get 4n squared minus 7n minus 11 equals 0. Let's see. Can I factor that? It'll be 11 and 1. Well, I think 11 minus 4 is 7, isn't it? Yep. Okay, here we go. Boom, boom, boom. There's a 0, there's a 4n and an n. Let's put 11 there and a 1 there. So 11 minus 4 would be 7. Perfect. And we want the 11 to be negative and the 4 to be positive. So then we got 4n minus 11 is equal to 0, and n plus 1 is equal to 0. So that means n is equal to 11/4, and n is equal to negative 1. Make sure I circle them so I'm modeling good behavior. Oh, here's another one with no just single x terms. So I subtract 13 from both sides, and we get negative 6x squared is equal to negative 13, which means x squared is equal to 13/6. And I square root both sides, and I get x is equal to the square root of 13/6, or negative square root of 13/6. Oh, this one's an easy one. Just square root both sides. We get x equals 8 or negative 8. Nice. They've got an x sitting over by itself. Got to get him on the other side. So we have 4x squared minus x minus 60 equals 0. Now, is that factorable? Need a difference of 1. Let's see. 6 times 10. No. 6 times, how about 5 times 12? Yeah, it's not looking good. I'm just going to throw the quadratic formula. X equals, so that would be negative 1, negative 1, which would be 1, plus or minus the square root of 1 squared, which would be 1, minus 4 times negative 60, so that would be plus. So what's 4 times 60? That'd be 16 times 60. 6 times 6 is 36. And 6 times 1 is 6, 7, 8, 9. 960. Wow. And then on the bottom, I'm going to have a 2 times 4, which is 8. So we end up with x is equal to 1 plus or minus the square root of 961 over 8. Whew, that's a big number. Is there any perfect square factors in there? Let's see, 6 and 7, or 9 and 7 is 16. I don't think so. I'm going to check the answer since we have them here. 11, 4, and negative 15/4. Oh, is that a perfect square? That can't be a perfect square, is it? 961. Well, what do you know? 961 is a perfect square. That's 31 squared. So that would be equal to 1 plus or minus 31 over 8. which would be 1 plus 31 would be 32. So that would be x equals 4. And 1 minus 31 would be 30, so that would be 30 over 8, which would be 15 over 4. That means that thing would have been factorable. Yep, okay. So let's keep going. So this is going to be, this is going to be 6x squared minus 3x minus 8 equals 0. Got to get everything on one side except for 0, right? And is this thing factorable? Looks like I gave up too easy on the other one. Let's try it. We could do, let's see, 6 and 1 or 3 and 2. This is 8 and 1 or 2 and 4. And we're trying to get a difference of 3. Let's see, 12 and 4, nope. How about 6 and 12 and 4, nope. How about 3 and 16, nope. Yeah, this is not looking good, is it? 2 times 3 is 6, 2 times 4 is 8. Ah, so close. Yeah, I'm going to give up and try the quadratic formula, because I know that'll work. So this is 6x squared minus 3x minus 8 equals 0. So that means x is equal to negative 3, which would be 3, plus or minus the square root of 9, plus, because it's a 4 times 6 times negative 8. And let's see, 4 times 8 is 32, and 6 times 32, 2 times 6 is 12, 3 times 6 is 18, 19. So that'd be 192 in there over 2 times 6 is 12. So that would be x is equal to 3 plus or minus the square root of 1, nope, 201. 201 over 12. And 201 I'm pretty sure is not going to be able, doesn't have any perfect square factors in it. Let's see, it is divisible by 3. Let's see, 201, if I put a 3 there, 3 times 6 is 18. Oh yeah, 3 times 67. So yep, so that would be my final answer. Okay, we're getting close to the end here, aren't we? Yep, 4 more. Okay, let's finish this baby. So that'd be 3n squared plus 6n plus 3. Always got to set it equals 0 first, right? Oh, I can divide everything by 3, so that'd be n squared plus 2n plus 1 is equal to 0. Oh, and that factors into, that's a perfect square factor, isn't it? Polynomial, isn't it? That'd be n plus 1 and n plus 1, wouldn't it? So that means n is equal to negative 1. Boom, move on. Okay, so this is going to be negative 3m squared minus 4m plus 55 equals 0. Is that going to be factorable? Let's try it. Equals 0. That'd be 3m. Oh, you know what? I think I'd get rid of that negative first, just because I don't like factoring negatives up front. So I'd multiply everything by negative 1. So that'd be a 3m squared and a positive 4m and a negative 55. And then I'd factor that baby. Okay, so 55 is 5 times 11. Ooh, that works good. So that'd be 3m and m. We'll put a 5 there and 11 there, because 3 times 5 is 15. 15 minus 11 is 4. So we want that to be positive and that to be negative. So then we have 3m minus 11 equals 0, and m plus 5 equals 0. So that means m equals negative 5. And m over here equals 11 thirds. Okay. Here we go. Got to get that 1 out of there. So that would be negative. And I'm going to actually, well, we'll just leave it at negative 8a squared plus 5a plus 16 equals 0. And I'm just going to go ahead and throw this quadratic formula because we haven't done that many quadratic formulas. X equals negative b, which would be negative 5 plus or minus the square root of 25 plus, because it's going to be 4 times a negative 8 times 16. So that would be see, 4 times 8 is 32. What's 32 times 16? 2 times 6 is 12. 3 times 6 is 18, 19. And 32, 2, 11, 5, 12. All over 2 times negative 8 would be negative 16. So then we get x. Actually, it's not x, it would be a, wouldn't it? Sorry about that. A, I wonder if I've done that before. A equals negative 5 plus or minus the square root of, and that would be 536 all over negative 16. I wonder if that's got any perfect square factors. Well, actually, that might, but that's not the right answer. This is 537. There we go. That is a prime number that does not have any. Actually, not a prime number. That's divisible by 3, isn't it? So let me, 537. 537 divisible by 3, so that'd be 3. Go in there once with 2 left over. Go in there 7 times with 2 left over. Oh, 179. And that's not divisible by another 3. Okay. So we're going to leave it like that. Perfect. Okay. One more here. And so this is going to be a negative 3n squared. Bring the negative 6n over, so that'd be negative 2n plus 1 equals 0. And I think we can factor that. Oh, maybe I'll multiply everything by negative 1. So that'd be 3n squared plus 2n minus 1 equals 0. Factor it, and we get 3n n and 1 and 1. And that'd make that a positive and that a negative. There we go. So that'd be n equals, whoops, sorry. That'd be n plus 1 equals 0 and 3n minus 1 equals 0. And this would give me n equals negative 1, and that would give me n equals 1/3. And that's the end of the worksheet. All right, happy equation solving.